All right. When we're graphing linear equations in two variables, of course we got to do the graph on our Cartesian coordinate systems here. Got a couple examples to talk about, and I'll pretty quickly here graph these, and perhaps you know already how to graph these, but we are going to talk about a lot of things about these here today. When we have linear equations in two variables, of course, by linear, we're referring to the fact that we've got degree 1, right? Degree 1 equations, and degree referring to power. So we're talking x to the first power equations, and y, but x really more specifically, but in terms of the y. But yeah, all these three examples here are all these linear equations in two variables. You got x to the first, x to the first, x to the first, also the y. But anyway, when you graph these, like I said, I'm going to do these quickly, and may or may not know I'm doing this, but this one turns out looking like this. And we could use a table. There's other ways, though, too. This one's going to look like this. This one is going to have slant the other way. Like that. It's 0, 4 there, and this one's 1, 1. This one's 0, 3, and 1, 5 if you're marking along there on your paper. All right, and this one, well, it's also a line, but turns out 1, 3, and then 1, 2. This one looks like this. Okay, so by sight there we can see what type of equations, what type of graphs do these linear equations turn into? Well, they're lines, and that's in the part of the name, so kind of where the name comes from. Yeah, the graph of these linear equations are all going to be lines, straight lines. Now, the one thing that we could point out is the slant of these lines, well, they're all different. This one's pretty steep. This one actually, usually when we talk about the slant, we go left to right. So this one's going uphill, left to right. This one's downhill. This one's going uphill, but it's not nearly as steep. And we'll talk about that some more. Well, just go ahead and mention it. That is the idea of slope, isn't it? Slope of a line tells me uphill, downhill, steepness, and all that good stuff. This one, well, this one is a positive slope, isn't it? Uphill lines run positively, positive slopes. Downhill lines have a negative slope. And so this one would also be positive slope. Okay. Yeah, uphill and downhill, positive, negative. Now, let me go ahead and also mention here, that there are two other types that we could have besides positive and negative slope. We could have straight, flat across there. This is your x, this is your y, and you have a straight across line, a horizontal line. That slope is turns out to be 0. And the other is the vertical line, straight up and down, and it has what slope of it is it? Anybody? Undefined. Okay, so that also could happen. So positive, negative, 0, undefined. Okay. But let's talk about slope a little bit, because on a line, that is one thing a lot of times you want to know is the slope of the line. And we'll talk more about the equation in just a second, but I did want to mention to you, what else do you know about slope? How do you determine slope? If you have 2 points, can't you determine the slope of a line? Yeah, there's a slope formula that we have for a line and we have 2 points on that line. There's a slope formula for it, right? For a line that goes through 2 points, and we know a point has an x comma y, and so we use 2 points, so we've got to use a little more designation there. We're going to call the first point x1 and y1 for first x and first y, and then the second point is x2 comma y2, because it's a different x and a different y, so we'll call it x2 and y2. So the slope formula, how does it go? For a line that goes through the point, the slope of the line is, well, first of all, let me mention again, the letter designation of slope is m, yes. So m equals, the slope equals, it's y2 minus y1, difference of the y's, over x2 minus x1. That is the so-called slope formula right there. Difference of the y's over difference of the x's. Okay? Just for practice here, let's do a couple of computations there. All right, so find the slope of the line. Through, how about 4, 7, and 9, 11? Well, that would be slope equals, this is being the just the first x, first y, second x, second y, so that's x1, y1, that's x2, and that's y2, right? So slope formula, take second y, 11, minus first y, 7, and then divide that by second x, 9, minus the first x, 4. So wind up having a slope of 4 over 5, 4/5. Of course, what you have to be careful with are negatives. So let's try this one. Find the slope of the line, and the points are -4, 2, and 6, -3. What's your slope there? Well, you take your second y, -3, minus the first y, 2, and then take the bottom, you take the second x, 6, minus the first x, which is -4. And note there, in the bottom, I have -4. And why do I have -4? Well, this negative is from the formula. This negative is the x, right? All right, so what we got here, we got -5. And then what about a negative? Yeah, it turns into a positive. So we have +10 on the bottom. The two negatives make a +4, so it'd be +10, which that does reduce by 5. So you have a -1/2. Slope of -1/2. So we've got a positive slope for the first one I did and a negative slope for the second one I did. So this one, uphill or downhill? That would be uphill. This one would be downhill. The other thing let me mention, with what we want to tackle next here is another way sometimes slope is referred to as rise over run. Slope is referred to sometimes as the rise over run. It's a ratio of the rise, how much from point to point you rise to how much point to point you run. And this is a good example here. This one says I rise 4 for every 5 I run. So from point to point, we rise 4 and run 5, or some ratio equivalent there. And obviously we could see that if we put those points down here. Let's see, 4, 7. Is that 7? One more. 7. Okay. So 4, 7 here, and then 9, 11. 11, 8, 9, 10, yeah, 11. So from this point to this point, yeah, I rise 4, and then I run 5 to get to that point. So that's another way to think of the slope. And here's my line. So it's rise to run. Let me dot those in instead. Rise 4, run 5. Now, of course, this one with being a minus half, what does that mean as far as rise over run? Well, a couple ways you could go. You could rise -1 and then run +2, or you could very well rise 1 and then run -2. That negative goes either one place or the other. So you can do it as a rise of -1, run a +2. You can do a rise of +1. So that would mean down 1 and then over 2. This would mean up 1 and then back 2. Right? Okay. Quick review of all that. All right. So all that being said, let's go back to the equations of lines. Well, the most famous of, pretty much most famous equation of a line is the so-called y equals mx plus b. Right? That's when you see a line, generally speaking, that's what you want of a line. You want y equals mx plus b, and that's similar to the ones, or a couple of ones I did earlier. The example number 1 that I had up here was y equals 2x plus 3. Well, the reason it's a pretty nice form of the equation is because right here, if we have this form, the m is just like we were just talking about. M is slope. Slope, same thing here. So if we have this form of the equation line, we can read the slope right off of the equation. And then the b, of course, x and y are the variables. The b turns out to be, what's b? Y-intercept. So for that reason, this form of the line is called the slope-intercept form of the line. Y equals mx plus b is the slope-intercept form of a line. So the line I've got right here then, kind of how I did the graph. I've got m is 2, and I've got b is 3, don't I? Okay. So what information does that tell me? Well, that tells me the slope is 2 of this line, and the b tells me the y-intercept of this line is going to be 3. Okay? All right, so that's important, like I said, important form. Now, what if I wanted to graph this, which I've already done previously? But let's talk about the graph of y equals 2x plus 3 then. Since I know this nice information here, can I graph this? Because I know, first of all, this is a line. How do I know it's a line? Well, it's x to the first, y to the first, 2. But I've got both the first powers there of x and y. So I know it's a line. And then I know the slope of the line, and I know the y-intercept of this line. So I can graph this thing, can I? How would I do that? Well, since the y-intercept's 3, what does that tell me? Where it crosses the y-axis. Okay, so I've got y-intercept 3 here. Crosses my y-axis right at 3. Also then, I have the slope is 2. Well, we were just talking about the slope being the rise over the run. If I think 2 as, I can think of that as a fraction 2 over 1. Isn't that my rise to my run? And so from point to point, for every 2 I rise or run 1. Well, here's a point on this graph, so wouldn't then a rise of 2, run of 1 put me right there? What's that, 5, 1? Rise 2, it's 5. Rise 2, and then run 1. Yeah, that puts me at another point on this line. That's enough to graph this. 2 points determine line. So once you got those 2 points, you can do some others, rise 2 and run 1 some more, but there you got it. Okay? With me on that. So far, so good? All right, well, let's talk a couple others here. Let's change it. All right, y equals negative 3x minus 1. Again, I just want to graph it. Well, that's our so-called y equals mx plus b line again, isn't it? Where in this case I've got the m is negative 3 and the b is negative 1. So what's this one going to look like? Well, the b tells me y-intercept. So it's going to cross the y-axis at negative 1. M tells me the slope, rise over run. So if I think negative 3 over 1 there, rise of negative 3, run of 1. Rise negative 3 means down 3. So I go down 3, and then run 1, which way? That's a positive 1 if I do it that way, so that goes to the right. Still going to the right. Even though I'm going down, I would still go to the right because that's a positive 1 run. There's your other point. What is that? Negative 4, 1, negative 4. Yeah, so you get this negative slanted line like that. Okay? All right. Now, what if I had another sort of format here? Let's say I had 3x minus 2y equals negative 8. And again, the goal here is a graph of this. We still talking about a line? Yes. Still talking about a line. Got x to the first power, y to the first power, so there's no different shape here. This is a line. But a couple of points here. This one has a little different format. First of all, is this y equals mx plus b? No, it is not. And so the point of that is the slope here is not 3 because it's not y equals mx plus b. The slope of this line is not 3 because to read the slope it has to be y equals mx plus b. I'll talk about that more later, but right now just note here the slope is not 3. It's a little different. on this one, to just show you another option here, I just need 2 points. And so if I get the x and I get the y-intercept, get the intercepts on this one, maybe do it a little differently than this way. And I had one earlier like this, and that's how I did it. But again, just to rehash the intercept thing, yeah, another way to do this one would be to get the intercepts. And we could do that one same way. We can do this one the other way too, and I will probably here in just a second. But yeah, if I just get the x and y intercept here, the x-intercept, you set y to be 0. So that would be 3x minus 2 times 0 equals negative 8. That makes that 0, so that's 3x equals negative 8. So that's going to put, divide by 3. The x-intercept is negative 8/3, which is negative 2 2/3. So it's going to cross the x-axis at a negative 2 2/3, which is right about there. And then the y-intercept, to get a second point, set the x to be 0. 3 times 0 minus 2y equals negative 8. That's 0, so it just makes it negative 2y equals negative 8, the equation. Divide by negative 2. So y is 4, is the y-intercept right here. So there's your y-intercept, there's your x-intercept, 2 points to determine a line, there's your line. Okay? So that's another way you can do these lines, is get the x and the y-intercept. Another way, just to mention it, always, if you don't know anything about the equation, this one I would hope most of us would know something, but you can always go back to a table, right? You can always set up a table, choose some x values, like we did on the worksheet earlier. But you could also do that. But let me mention the other way on this one, just to do this one a second way. What if I did want to use y equals mx plus b? Because we will have to do we'll have to utilize y equals mx plus b on such ones. What if I wanted to use y equals mx plus b on this? How would I do that? I have to get the y on one side. Yeah, I have to get the y to be on a side by itself. So I have to move the 3x, I have to move the minus 2, so to speak. How would I do that? Well, 3x minus 2y equals negative 8. So yeah, I'd move the x term first. That would be subtract 3x, both sides. So it would be minus 2y equals, and since I want mx plus b, let's write the x term first, right? Because I can't combine those terms. They're not. This one's not an x term, so I can't combine it with. So it's just minus 3x minus 8 on the right side over there. And then I would have to divide off the negative 2. Both sides. And that'll get me my y. Yeah, I'll get the y by itself, like we were saying. To get y equals mx plus b, you need the y on a side by itself. Now this negative 2 does divide both of these terms here. And a negative divided by negative gives me a positive. So it would be a 3/2 positive x. And that would be a positive 4, wouldn't it? Negative divided by negative is positive. And what we'd see is the same thing. You got b is 4. That's the y-intercept, which it is. The m is 3/2. So that would be rise to run. So I'd rise 3 and then run 2. And yeah, you get the same. So you get the same point, same line. Oops. Different point there on this, but you get the same. Okay? So yeah, there's 3 ways right there to do the graph of this. So pick Pick your poison there, whichever one you prefer. Okay? Questions? Any other questions or concerns?